start on
Revity Signals
Notebook, our cloud-based solution to store and manage all the data related to your experiments. Either on the dashboard or via the search, I can define and search for specific projects, experiments, or users. Once I identified the experiment of interest, I click on it and open it. This experiment already contains data. There is an introduction section with the tick boxes, articles in PDF format or Word documents. We have a compound section with all the used compounds for this special screen, but you can also get information about the used equipment. All these different section types can be added individually based on your specific request for that specific experiment. For the screening experiment, we have an image with the different control regions and also a Spotfire file embedded in Signals Notebook. A click on the Spotfire symbol opens the file in your Spotfire Analyst. This Spotfire analysis contains already raw data and additional layout information like concentration and reg IDs. Normalization is applied and a curve fit was performed, and all the important parameters of the curve fit but also a z-prime was calculated. If you want to perform a new analysis, you can open one of the existing predefined protocols. That opens a kind of wizard that guides you through the different steps of this protocol. For importing data, you just select via a drop-down the appropriate template. That template defines which of the information from the raw data file will be imported, like metadata or the raw values. You can select different data files and import them in batch. The defined information is extracted and creates a new data table. The structure of this data table is predefined in the protocol, but you can also manually adjust it. Once you applied this data structure information, it will be available in the next step of the analysis. The second step of the predefined protocol adds additional layout information. Again, you select from a predefined set of layouts the one which belongs to the experiment type. In this case, we have defined a concentration and a control area for these type of experiments. You can easily add a new layer to this protocol template. In this call, it's called test layer. And you can either type into this data grid or copy paste from any other data source. Once you have entered all relevant information, you can apply that design, and the new information is added as new columns to the data table. The next step in the protocol shows another way to bring in data. In this case, we want to add reg IDs, which are different on the different plates. You can either copy-paste data from other text sources, or you can type them in directly into the editable data grid. You can also decide if you want to add this new information as a complete new data table or as new columns which are added after a matching process to existing data tables. As we have added now all the relevant data to the data table, we can start normalizing the data. We define our controls and then from a drop-down can choose between different normalization methods, intra and interplate. Standard normalizations are available out of the box. If you need any other normalization, you can create them individually. After applying the normalization, you can compare the raw and the normalized data in different visualizations like box plots, heat maps, or histograms. You can select data points for exclusion or bring them back if necessary. Next in the protocol, we apply a completely customized calculation by using the Calculations Explorer app. Columns are mapped between the calculation and the new data table, and all the algorithms used for the calculation are applied to the new data table. In addition, predefined visualizations are created automatically as well. In our example, a Z prime is calculated per plate and shown in a histogram. A curve fit is applied, and if you enlarge them, you can look at the individual points of that curve, mark data points, and via right mouse click you can tag them directly for exclusion or inclusion, and the curve will be adjusted automatically. For each curve, you can browse the results directly in the result data table of the regression with all the parameters of interest. Additionally, a hierarchy is created where you can go from plate to the different reg IDs or compounds in that case and look at them individually. All windows on the screen are really flexible and you can move them around if you need more space. Within the settings of your curve fit visualization, you have access to the curve fit menu. Under the Manage Fittings tab, you get a lot of information about the existing fitting, but you have also the option to create a new fit. There are different fitting types available, and also a couple of options to define the fitting in more detailed. For example, if you want to have fixed values or fixed min and max. Different algorithms, like Levenberg-Marquardt or Y-weightings, are available as well. The new fit we just defined individually is applied to the data table and added to the visualizations. A new result table is created that contains all the relevant data like EC50 or other ECs you defined in the protocol, but also min, max, R-square, and so on. The last step in our protocol is publishing the data to a data lake. The results from the curve fit or the Z prime values can be published to a data lake and will be available for downstream analysis in Signals Inventor. To do so, we need to select the right data table and the measurement type. Measurement types contain all the relevant attributes which are published to the data lake. If we have selected a measurement type, all the identifiers and attributes are available and have to be matched with the right column in our data table. We can define manually which column contains which attribute or identifier, or we can use a predefined mapping template. For each attribute or identifier, the corresponding column is already defined in that protocol. If you save that mapping, you can reuse it the next time you run the same analysis. If you publish and there are data missing, you can define if you want to ignore them or use a replacement instead. Now you can decide if you want to save it as a new dataset or use it to modify an existing dataset. The defined results are now saved to the data lake and will be available for downstream analysis in Signals Inventor. The whole analysis file, containing all the modifications we did in this process, is saved back to the Signals notebook where we started our analysis.